All right, let's talk about ChatGPT. You've probably used it, maybe you even use it every day. Our goal today is to pull back the curtain and really get into what's going on behind that simple little text box. I mean, think about it. You type a question, you press enter, and boom, a perfectly written, coherent answer just appears. It feels like magic, right? But it's not. It's a really fascinating process. So let's try to answer that question and go on a little journey from what feels like magic to what's actually happening under the hood. Okay, let's dive right in. To really get a grip on what ChatGPT is, we've got to start at the very beginning, with its foundation, which is basically a massive chunk of the internet. See, before ChatGPT can be that helpful assistant that writes your emails, it has to go through this huge foundational training phase. You can think of it like it's elementary school, where its one and only job is to learn the basic patterns of human language. This first giant step is called pre-training, and the idea here is pretty simple. You just feed the model a gigantic amount of text. We're talking a curated, filtered version of pretty much the entire public internet. And when I say gigantic, I mean it. The scale is just mind-boggling. A modern training set has something like 15 trillion tokens. This isn't just a big number. It represents a huge slice of all the text on the internet. But that begs the question, what exactly is a token? Well, a token is basically the AI's version of a word. It breaks our language down into these little pieces, sometimes a whole word, sometimes just a part of one, like ing. This process, tokenization, is how it turns human language into something a computer can actually work with. And this is the absolute key to the whole thing. During this massive pre-training, the AI is doing one super simple thing, but it's doing it trillions of times. It just looks at a string of text and tries to guess the very next token. That's it. It's basically the world's most sophisticated game of what comes next. So, after all that work, what do we actually have? Well, we don't have an assistant yet, not even close. What we have is a base model. Think of it as a super powerful but kind of clueless internet simulator. It's a glorified autocomplete machine that's great at generating text that sounds like it's from the internet, but it can't follow instructions or answer your questions. So how do we get from that aimless text generator to the helpful assistant we all know? This is the next stage, and it's where we take that raw predictive power and give it a personality and a purpose. This is called supervised fine-tuning. Basically, a bunch of people are hired to create a perfect data set. They write thousands of conversations, showing the AI exactly how a helpful assistant should behave. Then they take that base model and train it all over again, but only on these perfect examples. It's like it's learning to roleplay as a helpful, harmless assistant by studying a script. And this quote from Andrej Karpathy just nails it. The implication is pretty wild when you think about it. When you're chatting with the AI, you're not really talking to some superintelligence. You're getting a statistical echo, a near-instant simulation of what the human labelers taught it to say. Its whole personality is a reflection of those examples. Okay, so now that we know how it's built, we can finally start to understand why it acts so weird sometimes. Knowing the how really unlocks the why behind its strange quirks. This is probably one of the most useful ways to think about it. All that internet pre-training is stored in billions of parameters. That's its long-term memory. It's huge, but it's also kind of fuzzy, like a dream you can barely remember. But the text you type into the prompt, that's its working memory. It's right there, crystal clear, and totally reliable. And that idea of memory perfectly explains why these things hallucinate or just make stuff up. See, in its training data, most answers are written in a confident, authoritative style. So the model learns to mimic that style. When it doesn't actually know the answer from its fuzzy long-term memory, it just fills in the blanks with what sounds plausible while still maintaining that confident tone. It's not lying, it's just completing a pattern. Here's another super important quirk to get your head around. For every single word or token it spits out, the model does a fixed amount of computation. It has a set thinking budget for each token. It can't just pause and think harder about a difficult problem. This means that to solve something complex, it needs to spread its reasoning out over many, many tokens. And this right here is a perfect demonstration of why that matters. If you ask it for an answer in a single number, you're forcing it to do all the math inside its head with a very limited thinking budget. And as you can see, it often fails. But when you tell it to think step by step, you're giving it permission to use lots of tokens to work the problem out. It creates a chain of thought, which makes the correct answer much more likely. So, let's put all this together. How does knowing this stuff actually help us? Well, it helps us stop treating the AI like a magical black box and start using it for what it is, an incredibly powerful but predictable tool. So here's the cheat sheet. First, give it context. Load up its working memory so it's not relying on its fuzzy recollections. Second, for anything hard, ask it to think step by step. Let it show its work. Third, and this is a big one, always verify its answers. It's a creative partner, not an oracle. And finally, just remember what you're talking to, a very sophisticated pattern matcher, not a person. Look, once you see behind the curtain and understand the mechanics, you can't really unsee it. It empowers you to be a much smarter user, to leverage its strengths and work around its weaknesses. So I'll just leave you with this. Knowing what you know now, how are you going to use it differently tomorrow?